Okay, I have some basic negative exponent work to do in 4 different examples. So I wanted to talk about the basic idea of a negative exponent. For example, when I have x to the negative 4, I know I have to take the inverse of x to the 4th, or 1 over x to the 4th. In other words, I know that I have to imagine that my whole number is a fraction with a 1 under it, and I have to flip it or invert it. If I have a negative fraction in my denominator, then I still have to invert it, so I have to basically send this number to the other side of my fraction. So I need to do x to the 4th over 1. The misleading thing here is it looks like that this operation is telling me to just flip the whole fraction, but the 1 is just a placeholder. So for example, if I had x to the negative 2 over y to the 2, I only have to send this number to the other side of the fraction line. It doesn't tell me to flip the whole thing. It just tells me that this one has to go here. The fact that my y to the second power doesn't have a negative tells me that it's where it should be. So we're left with 1 because there's nothing left on top. So 1 is sort of a placeholder. And then y to the 2, x to the 2. Once that negative exponential number is sent to the other side of the line, it loses its negative sign. The reason why there's still a 1 at the top, this might confuse you for some of you that are really trying to wrap your minds around it. It's because anytime I have a variable number or any number, you can think of it as 1 times that number, 1 times x. So when x itself moved to below the division line, 1 still was there, 1 remained. Okay, let's go back to this. Okay, so let's do this example next. So negative 2x to the negative 2. I find that this one is one of the most confusing examples because it has a negative 2, which means that it means that this is a 2 to the left of 0 on the number line, and not to the right of 0. So this is just a 2 that oh, my cat's coming to say hello. This is a 2 that is opposite of regular 2. Okay, so I have 2 different numbers here. I have negative 2, and it's times, and I have x to the negative 2. So my negative 2 does not have a negative exponent, so we're going to leave it on top of the division sign, and then x to the negative 2 does have that negative exponent, so it has to go down to the bottom, and then it loses its negative for the exponent. Okay, so let's look at this bottom one here now. Okay, the whole expression says negative 4 times x. Remember, if they're right next to each other, they're just multiplication operations. Negative 4, x to the second power, y to the negative 4th power, all over z to the negative 1. So if you look at the different numbers I have here, I have a negative 4, I have x to the second power, and then I have a y to the negative 4 and a z to the negative 1. So I circled them in different colors because I'm going to do 2 different things with those. The negative 4 gets to stay where it is. Let's draw another line here. The negative 4 stays where it is. the x to the second power stays where it is too. So I have 4x to the second power. This one travels below the line. So y, it becomes y to the 4. And then z travels up here because look, it has a negative sign. So it becomes z to the 1 up here, or even you can just write z. And then this is your answer.